Okay, number one. So a to the fifth times a squared. If it's side by side and you are multiplying, you're going to add the exponents. Answer a to the seventh. In the second one, you have a bunch of stuff in parentheses and you want to raise the stuff in parentheses to a power. Everything in the parentheses is going to raise to the negative 2 power. So this is 3 to the negative 2, x to the, when you go power to power, you multiply. So negative 2 times negative 2 is a positive 4. And this is y to the fourth. So 4, and then times negative 2 is a negative 8. So that's like our middle step. We're not done, but now we say anything that is a negative exponent is going to flip. So as of right now in this middle step, you kind of want to think of it as a fraction because everything was up top. Even though there wasn't a bottom, you want to think of it as over 1. And now anything that was a negative exponent is going to flip. So 3 squared is 9, but your 9 is going to be on the bottom. And x to the fourth has a positive exponent, so it doesn't go anywhere. And y to the negative 8th is going to go to the bottom. Final answer, x to the fourth over 9y to the 8th. Okay, number 3. So anything that has a negative exponent is going to move. If things land on the same line, you're going to combine them. So in the example of the a's, if you think about the example how we did it in class, how you had the fingers and you'd move them, this one would have 4 up top, 2 on the bottom, and these 4 are going to move to the bottom. Now the 2 on the bottom doesn't move at all. So the a's from up top have landed on the bottom along with these ones that were already there. So you have a total of 6 of them on the bottom. When you look at the b's, they're both negative, so they're both going to flip. So in reality, this ends up as b to the fifth over b to the third. And when you have things that are the same, but they're on the top and the bottom, this is when we cancel. So you're saying I have 5 of these things up top and 3 of these things on the bottom. So if you think of this as 5 letter b's and 3 letter b's, 3 of them will cancel down here with 3 of them up there, and it would leave you with b squared up top. Similarly with the c's, you have 4 of them up here, 2 of them down here. Neither of them are going to move because neither are negative. So I have 4 up top, I have 2 on the bottom. So I say I have 4 c's up top, and I have 2 c's on the bottom. So I can cancel 2 down here with 2 up here. Leaves me a total of 2 c's up top. For number 4, it's a fraction raised to a power. So everything in there is going to be raised to that power of negative 2. So this is 3 to the negative 2, x to the, our rules don't change, so power to power you multiply. So this is x to the negative 4 over 2 to the negative 2, and y to the negative 5 times negative 2 is a positive 10. So anything with a negative exponent is going to move. 3 squared is 9, but its exponent was negative, so that 9 is going to be on the bottom. 2 to the negative 2, 2 squared is 4, but again, its exponent was negative, so it's coming up top. X to the negative 4 is x to the fourth. Its exponent was negative, so it's going to move now on the bottom. And remember, when you move something, its exponent is now positive once it's been moved. And y to the 10th is already positive. It doesn't go anywhere. Your final answer is 4 over 9, x to the fourth, y to the 10th. How did I get the what? How did I get the 9? So 3 to the negative 2. So it's 3 squared normally is 9. But since it's a negative 2, that 9 is going to flip to the bottom. Another way of thinking of it as is this 3 to the negative 2 landed on the bottom as 3 squared. So just like I moved x to the negative fourth to the bottom and it became positive, 3 to the negative 2 one on the bottom is 3 squared, which was my 9. Okay, in 5 and 6, both problems say to find f negative 1 of x. And f negative 1 of x means to find the inverse. To find an inverse means to switch x and y. So let's start with that. We know that f of x is the same thing as saying y. So I want to take my x and my y, and the first thing I do is switch it. Nothing else comes along. No 2's, no exponents, just literally switch x and y. So x is equal to 2y squared minus 3. After you switch x and y, you want to solve for your new letter y. So to do that, I want to get y by itself. So I'm going to undo everything that's around it. First one is minus 3. So to undo that, I'm going to bring it over. And to do that, I add it. So now I have x plus 3 is equal to 2y squared. I'm trying to get down to y. Next step would be to get rid of this 2 out front. It's being multiplied, so I'm going to divide by 2. X plus 3 divided by 2 is equal to y squared. I don't want y squared, I want y. So to undo something that's squared, you take the square root of both sides. So x plus 3 over 2 is equal to y, and that is your inverse. For the second one, same directions, find the inverse. This is my y. So I want to switch x and y. So x is equal to the square root of y plus 5. Same idea, I'm trying to get down to y. Now I cannot subtract 5 yet because it's stuck underneath a square root. To get rid of the square root, you square both sides. So x squared is equal to, and when you square the right, what you're doing is squaring the left and squaring the right. And when you square the square root, it's gone and you're left with what was underneath. So I have y plus 5. And I just want to get to y, so I subtract 5. X squared minus 5 is equal to y. So you'll see in the first one, we went from something squared, something quadratic, and we landed at a radical. And then the other way around, when we started at a radical, when we found the inverse, we landed at a quadratic. So we said that radicals and quadratics were one of our inverse pairs. So whichever one you start with, you should land at the other. And an inverse is, if you were to graph these, it's a mirrored image across the line y equals x of the two graphs that you finished, the one at the end and the one at the beginning. Number 7 and 8 are the same kind of problem, just forwards and backwards. So if I'm going to radical form, radical means a root. I want these in underneath a square root. And we know that when you raise things to a fraction, the top part is the power and the bottom part is the root. So in both of these, for number 7, the root is 3, so we have a cube root, and it's x squared, y to the first, so it's just y. If you wanted to put a little 1 up there, that's fine, but it means the same thing. So going from exponential to radical is power over root, and since they're the same root on the bottom, we can put them together underneath one big third root. Number 8 is the same problem, but other way around. Now we're starting at a radical, and we want to land in exponential form. So I say, what is my root that they're both under? And that's a 6th root. So in your head, the fraction, the bottom part of it should be a 6, and the top part of your fractions are going to be the powers. So this is x to the 5 over 6, y to the 1 over 6. So radical to exponential or exponential to radical, you can go forwards and you can go backwards. The important part is that you know it's x being raised to the power over root. Okay, for number 9 and 10, same kind of problem. We're evaluating. So this is a number raised to a fraction. The top one is the power, the bottom one is the root. We always want to do the root first. So this problem asks us to find the 5th root of 32, and then we want to take that answer and raise it, and in this case to the 4th power. So your 5th roots, the 5th root of 32 is 2, and then you want to take the number 2 and raise it to the 4th power, and 2 to the 4th power is 16. For number 10, same idea. I want to start with the 3rd root. So the 3rd root of 27 is 3, and then I take my 3 and I square it, and I get 9. If you had one of these problems and the top number was a 1, so in other words, let's say you have 81 to the 1/2 power. Anytime the top part of your fraction is a 1, you're really just taking the root. So if I said the square root of 81, I've got 9, raising it to the 1st power would not change it. So anytime the top number is a 1, it's really just taking that root. If I said 27 to the 1/3 power, that's the cube root of 27, which is 3, and raising it to the 1st doesn't change it, so that would still just be 3. If it asks you to write the problem in standard form, we want to go backwards. So it's x minus each 0. So x minus 1, x minus 2, and x minus a negative 3 is going to be x plus 3. We want to multiply these out. So to multiply them out, this is really y equals. We're trying to come up with an equation. I want to take the first 2, and I want to FOIL them out. So first times first is x squared. The outer and the inner. So we have x times negative 2 is negative 2x. My inner is negative 1x. So the outer is negative 2x, and another negative 1x from the inner. So negative 2x minus another x is minus 3x. And last times last is a negative 1 times a negative 2 is a positive 2. We bring the third quantity down. And now we want to underline the group of 3. And everything in this group of 3 gets multiplied by x. And it also gets multiplied by 3. So starting with the x, I'm going to run the x through this. So x squared times x is x to the third minus 3x times x is 3x squared plus 2 times x is 2x. Now I want to take the 3, and here's a common error is that people take the 3 and they start multiplying it through the answer they just created. You want to take the 3 and it's going right through the same thing that the x just went through. So 3 times x squared is 3x squared. 3 times negative 3x is negative 9x. And 3 times 2 is a positive 6. And now you look at the terms you just listed and see if anything can combine. X to the third. There's no other third terms, so x to the third. And whenever you use one, I like to scratch it out so you don't see it anymore. Negative 3x squared and positive 3x squared. In this case, those cancel completely, so there's nothing left for the squareds. Positive 2x and negative 9x, so plus 2 minus 9 is a minus 7x, and we're left with plus 6. Y equals x to the third minus 7x plus 6. Okay, there are 3 types of variation, and they are directly, inversely, and jointly varying. And each one comes with a formula. So for direct variation, our formula is y equals, I'm going to change the color here for the letter k, and x. And the reason I'm changing the color is that k is the only thing I know for sure is going to be that letter and in that place. So when I do inversely varying, it's y is equal to k over x. And when I do jointly varying, it's y is equal to k and then 2 more letters. So you see in each one of these 3 formulas, you think of them as a blueprint, and the letter k is always going to be k, and it's always going to be exactly where you see it. The other letters, you have to read the problem, and you pick out the letters based on the problem they give you. When you do these, you want to think of it as a 3-step process. The first thing you want to do is find an equation. And then you want to solve for the letter k, and then you want to answer the question that is given. So the first thing we need is to find an equation. In other words, you want to know what type of variation you have. So let's make a problem up real quick. We will say that t varies inversely with p. If t equals 20, when p equals 10, find t when p equals 5. So we read this from start to finish, and we think of this as a 3-step process. The first thing I want to do is find an equation. So I start reading, and I see t varies. And we know that varies means equals. So t varies. How does it vary? It varies inversely. So you're immediately going to the second equation, and in your mind you're saying t equals, you know k is always going to be exactly where you see it, and then over something. And in this case, the something is a p. So t varies, so t equals. It's inversely, so you have this blueprint in your mind, k over something. So it varies inversely, k over inversely with what? In this case, the letter p. So step 1, check, we have an equation. Step 2, I want to find the letter K. So we keep reading. If T is 20 when P is 10, stop. We plug those in. If T is 20 when P is 10. If I want to solve for the letter K, I want to multiply both sides by 10. If I multiply each side by 10, this 10 is going to be gone, and over here I would have 200. So now I know that 200 is equal to K. Step 2, check. Now I want to answer the question. So I know that K is 200. So what is my question? Find T when P is 5. So my formula was T is equal to K over P. Find T when P is 5. And now you use the K that you just found in the last step, and I put that up here, and then your question is now just 200 divided by 5. T is equal to 40. We'll do another example with that. Let's do a jointly varying one. If it was directly, you'd use the top formula. Inversely is the middle. Jointly is the bottom. So using that same information, let's do A varies jointly with C and D. If A is 40 when C is 4 and D is 5, find A when C is 3 and D is 1. So lots of words, so you want to go really slow. And as we just said on the last piece of paper, we want to find an equation, find the letter K, answer the question. And you know this one talked about joint variation, so in your mind you have this blueprint. Something varies, the letter K, and then something something. So A varies jointly. So the second you see A varies jointly, you're saying A equals, and you have that blueprint in your mind of K something something. K always is where you see it. And then in this case, the something something is C and then D. So step 1, we found an equation. Step 2, we want to solve for the letter K. So I say, how do I do that? If A is 40, when? K, C, D. C is 4 and D is 5. So 4 times 5 is 20. So 40 is equal to K times 20. If I want to solve this for K, I would divide both sides by 20, giving me K being equal to 2. So now I have found an equation, I have found K, and now I want to solve the problem. The problem asks, find A, so A is equal to K, C, D. We know K is 2 now. Anytime you find K, we now use that. So K is 2. Find A when C is 3 and D is 1. 2 times 3 is 6, times 1 is still 6. The answer to your problem is 6. If it was a direct variation problem, it would be the same exact process. We're not going to do one, but same exact process, but you'd use the blueprint y equals kx. Okay, to factor this, it says 8x to the third plus 27y to the third. You're looking at this and you see 8 is a perfect cube, x to the third is a perfect cube, 27 is a perfect cube, and y to the third is a perfect cube. So if every single thing in your line is a perfect cube, you can factor them. So what they're giving you right here is, this is your a to the third, and this is your b to the third. So when you factor this, you have to know the blueprint, and the blueprint is small set of parentheses, large set of parentheses. And it goes a, b, a squared, ab, b squared. And for your symbols, they're going to be the same, the opposite, and always positive. The same meaning in this case it's a plus problem, so I'm going to go same, opposite, always positive. So what they gave me was 8x to the third. That's my a to the third. And I want to take that and make it a. So if I want to go from a to the third to a, I'm taking the cube root of this whole term, including the letter. So the cube root of 8 is 2, and the cube root of x to the third is x. So this is 2x. the cube root of 27y to the third is 3y. I now want a squared. I have a, so if I want a squared, I square the a term, which gives me 4, and don't forget to square the x, so x squared. I always hop to the back term, because if I just squared the front, now I want to square the back. So if I square my 3y, I end up with 9y squared. My symbols are same, opposite, always positive, and we need to fill in the middle part here. The middle part is a times b. What is my a and my b? So 2x and 3y. 2x and 3y gives me 6xy. Now comparing that problem, that's the answer, you're done. But a lot of us confuse that with something that looks like this. It would say solve. And let's say it was 3x to the third is equal to 27x. If we were to solve this, we get everything to the left. So 3x to the third minus 27x is equal to 0. And people see x to the third and they start thinking cubes, which is not a bad idea, but 3 is not a perfect cube root, nor is the x that's attached to the 27, so you cannot do that. You have two terms, you start asking yourself, is it squares, is it cubes, and if not, we take stuff out. It's not squares, nothing there is a square. We just ruled out cubes. The only thing left is to take stuff out. I can divide this out by a 3 and also by an x. And that leaves me x squared minus 9 is equal to 0. So when I look at this, I have another set now of two terms, x squared minus 9. So anytime you have two terms, we're just covering everything up but the x squared minus 9. Anytime you have two terms, you're saying, is it squares, is it cubes, or should I take stuff out? Hopefully we see x squared minus 9 is the difference of squares. So that would refactor. So I'm going to bring my 3x up. And then I have x plus 3, x minus 3, and we're setting them all equal to 0. The 3x equals 0. You solve it, you get 0. X plus 3 gives me a negative 3, and x minus 3 gives me a positive 3. Okay, this problem asks us to combine these radicals. To add or subtract a radical, we need the same exact number underneath the radical. So first step is to take each radical and break it down. So I'm going to say the first one is 4 times 200 will be 100 times 2. The second one would be 9 times 2. And the last one would be 25 times 2. So when I take these square roots, remember when you break down a perfect square, it's perfect square times something to create what you just had. The square root of 100 is 10. And this number out front is a multiplier. So 10 times 4 is 40. And I'm left with my root 2. In the middle one, the square root of 9 is 3. And 3 times 3 is 9, root 2. The last one is the square root of 25 is 5. But 5 times 4 is 20, root 2. Now when you look at these, all three of them have a root 2, root 2, root 2. Now you can do your math. 40 plus 9 is 49, and 49 minus 20 is 29. Square root of 2 is your final answer.